We are given the function j of x, and we are tasked with identifying the domain and classifying each type of discontinuity of this function. So as always, our first step is to factor this function here. So let's start with the numerator. We have x squared plus x minus 6. If we use our diamond method here, in the top quadrant, we're going to put a times c, which is going to give us negative 6. And in the bottom quadrant, we're going to put 1 because that is our b term of this trinomial. We now want to find the factors of negative 6 that add to equal 1. And so those are going to be 3 and negative 2. 3 times negative 2 gives us negative 6. 3 plus negative 2 gives us 1. Because our lead coefficient is 1, we can go ahead and write our numerator in factored form just by adding these factors to x. So that would leave us with x plus 3 times x minus 2 in our numerator. Now looking at our denominator, we have x squared minus 9. We might recognize this as a difference of squares and write it in factored form immediately, but if we don't see that right away, we can again use our diamond method. Our a times c is negative 9. We don't have a term with x, so our b term is 0, meaning that our two factors are going to be 3 and negative 3. And again, our lead coefficient is 1. We can go ahead and write this in factored form by adding these factors to x, leaving us with x minus 3 times x plus 3. Now I want to identify the domain of our function. So to do that, we need to find our domain restrictions, or the values of x that make our denominator equal to 0. So because we've already written our function in factored form, we can do that by finding the x values that make each of these factors equal to 0. So what we want to do is we want to set these factors equal to 0, x minus 3 equal to 0, and x plus 3 equal to 0. And then when we solve for x, we find that the two values of x that will make our function undefined are 3 and negative 3. So that would mean that our domain is all real numbers except for x equals 3 and x equals negative 3. So all real numbers except x equals 3 and x equals negative 3. We've identified our domain restrictions, but now we want to classify them. So at these two values of x, do we have holes or vertical asymptotes? So holes occur when we have a factor that occurs in both the numerator and the denominator. In other words, holes occur at the x values that make both the numerator and the denominator equal to 0. So here we would have a hole at x equals negative 3 because x equals negative 3 will make both our numerator and our denominator equal to 0. Now we have one more domain restriction to classify. This factor, x minus 3, occurs only in the denominator and not the numerator. So we say that x equals 3 is our vertical asymptote because it makes only our denominator equal to 0. So now looking at part B of this question here, we see that at x equals negative 3, we have an open circle. And an open circle on our graph represents a hole. So that checks out because we found that we have a hole at x equals negative 3, and there is an open circle where x equals negative 3 on our function. And finally, where x equals positive 3, we see this blue dotted line that our function is approaching but not crossing. So that again checks out. We have a vertical asymptote where x equals 3. Now identified our domain restrictions.